It's time to get your arrows popping. Ladies and gentlemen, this is Mr. Witt with Fort Bend Tutoring, and today we have a tutorial for you about multiplying matrices. That's right, matrix multiplication. And before we begin, I'll ask that you subscribe to the YouTube channel Fort Bend Tutoring, and also to click on that bell icon so that you can be notified when we're uploading new and fresh content for you. Yeah, go ahead and click on that, please. Yeah, okay. And before we dig in, I actually have a gift for you, and that is a snapshot of the problems that we'll be looking at today. That's right. I'm giving you 1, 2, 3, 4, 5 problems that we'll be tackling today, but we have an additional 3 on top of that. So the last time we checked, 5 plus 3 gives you 8 total examples in this video about multiplying matrices. Let's go ahead and get that Mr. Witt in view. There we go. All right, so you know what problems are going to come up. So let's go ahead and talk about the strategy involved in multiplying matrices. Well, what you'll need to know is that in order to multiply matrices, you'll need to verify that the order of each matrix is compatible with the other in order to multiply the matrices. So what do I mean by that? I mean that the order of a matrix is defined by the rows, meaning the horizontal values, by the columns, which are your vertical values here. And for instance, in this first matrix that has elements A, B, C, D, E, F, we'll say that the order of this first matrix is a 2 by 3 matrix. That's right, because it has 2 rows as well as 3 columns. So this is a 2 by 3 matrix. Now, the second matrix that we have has 3 rows and 1 column. Therefore, the order of this second matrix is a 3 by 1 matrix. And you'll want the columns from the first matrix to match the number of rows of the second matrix when multiplying matrices. So let's go ahead and highlight the fact that the columns of the first matrix and the rows of the second matrix, they matched. And that is going to verify that these two matrices can truly be multiplied together. That's right. And now using this information, we can predict the order of the resultant matrix. How do you do that? Well, basically it works like this. The rows of the first matrix and the columns of the second matrix will dictate the order of the resultant matrix. So I know that the product of these two matrices is going to end up giving us a 2 by 1 matrix, meaning that the answer of these two matrices multiplying together will be a matrix that has an order that is 2 by 1. 2 rows, 1 column. And that's going to be represented by what you see right here. See, this is a 2 by 1 matrix. And that value of A is going to be derived by multiplying each of the corresponding elements within both matrices in that first row and then the first column in order to obtain the products of each of those corresponding matrices, and you'll find the sum of those products. Yeah, sounds complicated, right? Well, you're going to be doing the same thing in order to get that value of B. You'll be taking that second row and then multiplying each of the corresponding values in that first column here with that second row in order to come up with the B value. That is going to be the result of you multiplying D times G plus E times H plus F times I in order to come up with that value there. And trust me, I understand that this is not that cute, but as they say, seeing is believing, right? So that's why I'm going to show you how this plays out in the 8 examples that we have in this video. So let's go ahead and get started. Here we have problem number 1. So the first thing you want to do with the fact that I have this first matrix that contains 6 and -3, while my second matrix contains the elements -5, 4, we want to verify that these matrices are compatible by checking out the values of the columns of the first matrix with the rows of the second matrix. So let's get to identifying the order of both of these matrices. Well, the first one is a 2 by 1 matrix. That's right, because it has 2 rows and 1 column. And then this second matrix has 1 row and 2 columns. So what we want to identify is whether or not the inside values match. That's what we want. And lo and behold, they do, because they're both 1. Yeah, they both have a value of 1. See, the columns of the first matrix is 1 and the rows of the second matrix is 1. Therefore, they match. There you go. They're twins. So due to that, I know that the resultant matrix is going to be a 2 by 2 matrix. Yeah, because I'm taking the outside values to determine the resultant matrix. See, the 2, as far as the rows of the first matrix, and the 2, that is the columns of the second matrix, is going to be used to determine the order of our resultant matrix. So let's go ahead and set this up. So I'm going to open up this matrix right here to show you the process that we'll be utilizing in this video to create our products when multiplying matrices. And that is, I'm going to go across and down. That's all I need to remember. Across and down is going to be the process that I use in order to derive the elements in our resultant matrix. Yeah. For instance, in this upper left-hand corner, I'll be multiplying 6 times -5. In order to get the value that will reside in the upper left-hand corner of my resultant matrix. Yeah. And then I'm going to go across and down this second column to get that second element in the first row here. Yeah. It's going to be 6 times 4. So now we'll be multiplying across the second row and then down the first column. So I'll be multiplying -3 times -5 to get the value in the lower left-hand corner of my resultant matrix. And finally, for the lower right-hand value, we're going to go across the second row and down the second column in order to come up with -3 times 4. And so here is our setup for our resultant matrix. And now all you got to do is simplify this. So you'll have 6 times -5 to give you -30. You'll have 6 times 4, that's 24. You'll have -3 times -5 to give you +15. You'll have -3 times 4, that gives you -12. And this is going to be your answer, guys, for problem number 1. Yeah, just like that. Red box it. That's right. Go ahead and put your answer in a red box. And there you go. That is problem number 1. Let's move on to our next problem. In problem number 2, we'll be attempting to multiply these two matrices together, but first we'll need to verify that these matrices are compatible with one another. We know that the first matrix is a 2 by 2 matrix because we have 2 rows, 2 columns. We also have another matrix that is a 2 by 2 matrix as far as the order is concerned. I hate that 2. We're going to fix the 2. That's not even a better 2 yet. Okay, there you go. There you go. We're going to roll with that 2. Yeah. So practically it's guaranteed to be doable because the inside values are identical to one another. Yeah, and they would be because this is a square matrix times a square matrix. So the numbers are going to be the same. And that also means that our resultant matrix is going to be a 2 by 2 matrix as well. Because once again, you take those outside numbers to come up with the order of your resultant matrix. And that's exactly what we're doing here. So what we're going to do now is open up our work area here where we will be setting up our process to get this done. And remember, I'll be moving across and then down to come up with the 4 elements that will be in our resultant matrix. So let's begin like this. We're going to begin by multiplying the corresponding elements together and work across and down as we go. So what do I mean by that? I mean that I'll be multiplying -5 times 3, then adding to that 2 times 6, and this will give us our first element in our resultant matrix. Then you're going to go across and then down the second column. So I'm going to have -5 times -5. Let's go ahead and show that like so. And then 2 times -4. And you're going to be adding that product together. There you go. And then we're going to be coming down to the second row and then multiplying the first column there. You're going to have 1 times 3 plus 5 times 6. And now for the last element, we'll be going across the second row and down the second column. So we'll have 1 times -5 plus 5 times -4. All right. And then we're going to be simplifying this. So in our first element, we have -5 times 3. That gives you -15. Plus 2 times 6 is 12. For the second element, we have -5 times -5 is 25. 2 times -4 is -8. Then you have 1 times 3. That gives you 3. plus 5 times 6 is 30. And finally, you have 1 times negative 5 gives you negative 5, and 5 times negative 4 is negative 20. Continuing our simplification, negative 15 and positive 12 gives us negative 3. 25 minus 8, that's going to be 17. 3 plus 30, that gives you 33. And then we have negative 5 and negative 20 to give you negative 25. All right. And this right here with the ugly 3 that will be getting changed right now. Thank you. Oh, my God. That's a little better. You have your answer. Red. Box it. All right. Let's go ahead and gift wrap our answer. There we go. That's problem number 2, guys. We have a result of negative 3, 17, 33, and negative 25. And that is problem number 2. All right. So this is just a reminder, guys, for you guys to feel free to set up a paid online tutorial today with me, Mr. Witt. That's right. Just check out our website, tutormemath.net, to get that underway. And it doesn't matter where you are in the world, as long as you have internet. We can use either FaceTime or Skype to tutor you as an individual or a group or a classroom with your math topics of the day. There you go. So check out our website, fortbentutoring.com or fbtmath.com. It'll get you there. Number 3, we have a 3x1 matrix, and we have a 1x2 matrix, guys. So the question is, are these two matrices compatible as far as matrix multiplication is concerned? Remember, in order for them to be compatible, the columns of the first matrix must be identical to the value of the rows in the second matrix. And they are. They're both 1, right? So let's go ahead and identify that since our inner values are the same, that we can multiply these two matrices together. We'll also keep in mind that the outer values will tell us the order of the result. So this is going to be a 3x2 matrix that we'll end up with. So setting this up here, all right, just like this, we'll be going across the first row and then down the first column in order to create our first value that we'll have in our resultant matrix. That means that I'll have negative 5 times 3 for that first value, and then I'm going to go across the first row and down the second column, and I'll have negative 5 times negative 1. And then from there, we're going to go across the second row and then down the first column. You'll have 6 times 3. Then going across the second row and down the second column, we'll have 6 times negative 1. Then we'll be on our third row going across and then down. This gives us 1 times 3. And then finally go across the third row and down the second column to come up with 1 times negative 1. And this is going to be our setup for our 3x2 matrix. Okay, let's see what happens. We have negative 5 times 3. That gives us negative 15. You'll have negative 5 times negative 1. That's positive 5. You'll have 6 times 3, which is 18. You'll have 6 times negative 1 is negative 6. 1 times 3 gives you 3, and 1 times negative 1 is negative 1. And this is our answer for problem number 3, guys. Just like that. Red, box it. Here we have our result right here. There you go. That's problem number 3. Problem number 3. Not bad. And moving on, thank you, we have problem number 4, guys. And we have 2 matrices ready to be multiplied together. Let's see how this works. We have the order of the first matrix because we have 2 rows here. We're going to say it's going to be 2 by 3. 2 rows, 3 columns. And in the second matrix, we have another 2 by 3 order. Yeah, we do. In order to make sure these 2 matrices are compatible with one another, the columns of the first matrix must be identical to the rows of the second matrix. And that is not the case in this problem because 3 does not equal to 2. So the answer to this is undefined. Right. Well, see, it's not even compatible. Therefore, we can't multiply together. So there's no solution to this problem. So therefore, you can write it as undefined. You can say it's no solution. We can say it's the empty set. We can say that it's the null set. There's various ways to go ahead and write our result. It depends on you and your teacher. Okay. So any of these will do. There you go. Bottom line, you can't multiply these two matrices together. That's what you want to take to the test. Yeah. And to the grave. There you go. Don't tell anybody. Red box it. That's right. We're going to red box our answer. Just like that. There you go. Let's keep that little secret and move on. We have problem number 5. And with this problem, I'm looking at a 3x3 matrix. That's right. 3 rows, 3 columns. A square matrix. That's what that is. We have another 3x3 matrix. Oh, yes, I do. Do the inner values match? That's the question. Do you know the answer? They do. 3 equals to 3. These matrices can be multiplied together. We just verified that. The resultant matrix is going to be a 3x3 matrix. Yes, it will. Let's go ahead and set this up. I'm going to give myself a little room to work with, if you don't mind. Thank you. And what am I going to do? I'm going to be moving across and then down. That's what I'm going to do. All right, let's give ourselves some room to work. Giving ourselves some room to work here. So what are we going to do here? We're going to find out our element that goes in the upper left-hand corner. And you'll be multiplying -4 times 5. Remember, going across and then down. Plus, you'll have -2 times -1 plus 2 times 0. And that gives you that first element in the first row. There you go. Then we'll be going across and then down the second column. So that means I'll have -4 times -3 plus -2 times -2 plus 2 times 4. All right. Then I'm going to end up with, for this value right here, for this element here, let's go ahead and see if we can squeeze it in. We're going to be going across and then down the third column. You'll have -4 times 3 plus -2 times 2 plus 2 times 1. Okay, there we have it. All right. We just squeezed all of that in that space right there. Oh, yeah, it's ugly. But it'll be fine. Moving on to the second row, then going down the first column. We'll have 5 times 5 plus 3 times -1 plus 0 times 0. Then second row, second column. You'll have 5 times -3. You'll have 3 times -2. You'll have 0 times 4. Second row, third column. We'll have 5 times 3. You'll have 3 times 2. You'll have 0 times 1. All right. Now, going across the third row, down the first column, you'll have 1 times 5 plus -1 times -1 plus -3 times 0. We move across the third row and down the second column now. You'll have 1 times -3, -1 times -2, and -3 times 4. Finally, we'll have the last row times the last column. You'll have 1 times 3. You'll have -1 times 2, and you'll also have -3 times 1. All right, so this is going to be the setup for constructing our resultant matrix for problem number 5, guys. Now, as we simplify, we're going to have -4 times 5 gives you -20. This is going to be -2 times -1. That's a +2. You have 2 times 0 is 0. Then you have -4 times -3. That's a +12. -2 times -2. That's +4. 2 times 4 gives you 8. Then we have -4 times 3 is -12. You have -2 times 2, that's -4. And 2 times 1 is 2. And that takes care of our first row. Moving on to the second row. You'll have 5 times 5 is 25. 3 times -1 is -3. And 0 times 0 is 0. Moving on, we have 5 times -3. That gives you -15. 3 times -2 is -6. And 0 times 4 is 0. Second row, third column, we'll have 5 times 3 is 15. You'll have 3 times 2 is 6. And we'll have 0 times 1 is 0. Then on our third row, we'll have 1 times 5 is 5. -1 times -1 is +1. And -3 times 0 is 0. We'll then multiply 1 times -3 to get -3. -1 times -2 is +2. We'll have -3 times 4 is -12. And then third row, third column, you'll have 1 times 3 is 3. -1 times 2 is -2. And -3 times 1 is -3. All right, now we're going to be continuing this simplification process, making sure that all of our values are in their proper place. -20 plus 2 is -18. Plus 0, it stays -18. Well, I have -18. 12 plus 4 is 16. 16 plus 8 is 24. -12, -4 combine to give us -16. -16 plus 2 is -14. On to the second row, we have 25 minus 3 gives you 22. Then you have -15, -6 gives you -21. -21 plus 0 is still -21. Adding 15 plus 6, you get a +21. Add 0 to that, it stays 21. In the last row, the third row, 5 plus 1 is 6. 6 plus 0 is still 6. Then you'll have -3 plus 2 is -1. -1 and -12 combine to give you -13. Then finally, we have 3 minus 2 is 1. And 1 minus 3 gives you -2. And this is going to be your answer, guys. Done and done. Red, box it. That's right. We have our 3 by 3 result, our square matrix as a resultant matrix, and that was problem number 5, guys. Let's move on to the next problem. All right, in problem number 6, I want to verify that these two matrices are compatible, and we'll have a 1 by 3 matrix, and we'll be trying to multiply that with a 3 by 2 matrix. So are these two matrices compatible for multiplication? Is the value of the columns in the first matrix the same as the value of the rows in the second matrix? Well, that value is 3 and the other is 3, so yes, they match. Using the outer values, we're predicting the order of the resultant matrix, and it's a 1 by 2 matrix. Yes, it is. All right, so let's go ahead and set up our area here. We're going to have a 1 by 2 matrix, and let's not forget that we'll be moving across and then down. So that means that this first value is going to be the result of -6 times -3 plus -4 times -6 plus 4 times 6 to give us that first value there. Then we'll have -6 times 2 plus -4 times 0 plus 4 times -2. All right, had to squeeze it in, guys. Had to squeeze it in. Okay, there you go. Yes, I should have made more room. I didn't. So continuing on. Simplifying, we'll have -6 times -3. That gives me 18. I'll have -4 times -6. That gives me +24. We have 4 times 6. That gives me +24. And now, for the second value, you have -6 times 2 is -12. -4 times 0 is 0. And 4 times -2 is -8. All right, let's go ahead and combine these values for our result. 18 plus 24 is 42. 42 plus 24 is 66. -12 plus 0 is -12. -12 minus 8 is -20. Ladies and gentlemen, this is the answer right here. Red, box it. There we go. There we go. That is the answer to problem number 6, guys. 66, negative 20. That's our result. Let's move on. Let us move on, please, to problem number 7, guys. Problem number 7. We have values of negative 3, negative y, negative 3x, negative 4 in the first matrix. That's right. They're giving us variables now. Thanks. In the second matrix, we have negative 4x, 0, 3y, and negative 2. Yeah. They want to know if we can multiply these two square matrices together. Well, we do know that the order of the first matrix is a 2 by 2. The order of the second matrix is a 2 by 2. We know that the inner values are identical. We're dealing with square matrices. How can they not be? And we also know that our resultant matrix will also be a 2 by 2 matrix. Let's make this happen, guys. They think that we're fearful because they have variables. Let's show them that we don't care. Our process is to move across and then down. And that's exactly what we're going to do. I'll start out in the upper left-hand corner with negative 3 times negative 4x plus negative y times 3y. Going across the first row, down the second column, we have negative 3 times 0 plus negative y times negative 2. Moving to the second row, we're going to go across the second row, down the first column. This gives us negative 3x times negative 4x. Add to that, negative 4 times 3y. Negative 4 times 3y, just like that. Then you're going to go across the second row, down the second column. Thank you. You'll have negative 3x times 0. Negative 3x times 0. Add to that, negative 4 times negative 2. Negative 4 times negative 2. There you go. There you go. We want to simplify this, guys. When multiplying negative 3 times negative 4x, you'll get positive 12x. Multiplying negative y times 3y, that's negative 3y squared. And this is the value of the upper left-hand element in your resultant matrix. Yes, it is. We have negative 3 times 0. Well, that's 0. And I guess we can put these in parentheses for now. This is going to be 0. And then add to that 2y, because when multiplying negative y times negative 2, you end up with positive 2y. Yeah. In the second row, we have negative 3x times negative 4x. That gives you a positive 12x squared. Multiplying negative 4 times 3y, that's negative 12y, guys. Then multiplying negative 3x times 0, you get 0. Multiplying negative 4 times negative 2 is positive 8 all day, every day. Thank you. Let's write our answer. We'll have 12x minus 3y squared. That's that first value. You'll have 2y as a second value. You'll have the 12x squared minus 12y as the element in the second row, first column. And then finally, you'll have this number 8, because 0 plus 8 is 8. Thank you. And this is the answer. Red box it. That's right. Go ahead and red box your answer. There it is. Done and done. All right, people. Let's go ahead and move on to problem number 8. In problem number 8, we have a 4 by 3 matrix. Multiply that with a 3 by 2 matrix. That's what we're doing here. That means that our resultant matrix, given the inner values are identical to one another, this means that our resultant matrix is going to have a 4 by 2 order. 4 rows, 2 columns. Let's set it up. All right, so let's see how this plays out, guys. We're going to be multiplying across and then down. So I'm going to end up with negative 1 times 0 plus 1 times negative 1 plus negative 2 times 2. That gives me the first element that I have in the first row of the resultant matrix. Yeah. Then we'll be going across the first row and then down the second column. So that means that I'll have negative 1 times 4 plus 1 times negative 3 plus negative 2 times 1. That's what I got there, guys. Now we're going across the second row, down the first column. This gives me 5 times 0 plus 2 times negative 1 plus negative 4 times 2. All right. Moving on to that second row, second column value. So we go across the second row, down the second column. 5 times 4 plus 2 times negative 3 plus, oh, that's an ugly plus, fix it. Thank you. Then we have negative 4 times 1. There we go. Better. We're on to the third row. Go across the third row, down the first column. You'll have 6 times 0 plus negative 3 times negative 1 plus 1 times 2. Just like that. Go across the third row, down the second column for our next element. You'll have 6 times 4 plus negative 3 times negative 3 plus 1 times 1. We're now moving across the fourth row, down the first column. This gives us negative 5 times 0 plus 7 times negative 1 plus 0 times 2. And now we'll be moving across the fourth row, down the second column. You'll have negative 5 times 4 plus 7 times negative 3 plus 0 times 1. Yeah. All right, simplifying. Let's go ahead and get set up here. All right. We'll have negative 1 times 0 is 0. 1 times negative 1 is negative 1. Negative 2 times 2 is negative 4. Next, we have negative 1 times 4 is negative 4. 1 times negative 3 is negative 3. Ain't that negative? Let's fix the negative. Negative 3. Negative 2 times 1 is negative 2. Then to the second row, we have 5 times 0 is 0. 2 times negative 1 is negative 2. Negative 4 times 2 is negative 8. Moving on, we have 5 times 4 is 20. 2 times negative 3 is negative 6. Negative 4 times 1 is negative 4. Moving on to the third row, we have 6 times 0 is 0. Negative 3 times negative 1 is positive 3. 1 times 2, that's 2. Then we all have 6 times 4 is 24. Negative 3 times negative 3 is positive 9. 1 times 1 is 1. Then for the fourth row, you have negative 5 times 0 is 0. 7 times negative 1 is negative 7. 0 times 2 is 0. And now you'll have negative 5 times 4 gives you negative 20. 7 times negative 3 is negative 21. And 0 times 1 is 0. Your resultant matrix will have the following values. We'll start out with 0 minus 1 is negative 1. Negative 1 minus 4 is negative 5. You'll have negative 4 minus 3. That gives you negative 7. Negative 7 minus 2 is negative 9. Then you have 0 minus 2 is negative 2. Negative 2 minus 8 is negative 10. 20 minus 6 gives you 14. 14 minus 4 is positive 10. Third row, we'll have 0 plus 3 is 3. 3 plus 2 gives you positive 5. 24 plus 9 is 33. 33 plus 1 gives you 34. In the fourth row, we have 0 and negative 7 give you negative 7. Negative 7 plus 0 is still negative 7. Negative 20 minus 21 gives you negative 41. Negative 41 plus 0 is negative 41. Ladies and gentlemen, this is your answer. Red, box it. All right, got our red box right here for problem number 8, guys. That's right. All right. Let's turn the page here. So that wraps up this video on matrix multiplication, guys. Thank you so much for hanging in there all the way to problem number 8. If you went all the way to problem number 8, go ahead and leave a comment in the comment section, please. And as always, please rate, comment, and subscribe to the YouTube channel Fort Bend Tutoring. I would really appreciate it if you shared this video with somebody that you know and love, all right? And somebody that you hate. Peace.
Thanks for watching. We appreciate you hanging out with Fort Bend Tutoring. Like the video, comment, and subscribe. Hit up our website, tutoringmath.net, and set up a private tutorial with me and FBT. Oh, yeah, baby.